notes, which is on solving equations with variables on both sides or on each side of the equation. And this differs a little bit with what we were doing the other day, but definitely does have some review involved. For instance, if we look at number 1, I would notice that all of your variables are on the same side of the equation. So your goal is to simplify this and then completely solve for x. So if you're thinking about the order of operations and thinking, should I multiply or should I combine first? The answer is always multiply. So I'm going to distribute in that 2. I'm going to leave the 6x because that's not being multiplied. So we'd have 6x plus 2 times 4x, which is 8x, 2 times negative 1, which is negative 2, equals positive 26. Then I look at this side and notice that I can combine these like terms, and I can make the equation more simple to be 14x minus 2 equals 26. And then my goal is to get x isolated. So the least attached number to x is negative 2. If I want to move that to the other side, I'm going to add that, cross these out, combines to be 0. 14x equals 28. These are currently being multiplied, so the inverse is division. 28 divided by 14 is a nice answer of x equals positive 2. So number 1 should be a review from earlier in the week. However, the reason I put number 1 here is to look at number 2. And notice that we have variables not on the same side this time, but opposite. So what we need to do, instead of combining the like terms on one side, we need to move the like terms. And when we move a like term, we need to do the inverse or opposite operation. So if I want to get my x's together, you're going to notice that I tend to get the variables together first. So what I'm going to do is move the 3x to the left side. I've noticed that more students like moving things over to the left, so I'm going to do that most of the time. So I have 8x minus 3 equals a positive 13. And now this equation reminds me of this one quite a bit, that now I want to get x isolated. So I'm going to add the 3, get 8x equals a positive 16. Funny enough, if I divide by 8, definitely planned, the answer is also x equals 2. If we carry on to the next example, this is one here that I would like you to pause the video at this time, and number 3 is similar to number 2. So if you could try this on your own first and check with me, I think it would be more valuable. So please pause now. So to go through my work on number 3, I noticed that the variables were not on the same side of the equal sign, but opposite. So I wanted to get my variables together first. So because this was a positive 4n, I decided to subtract 4n to get rid of it over here, but combine with this one. So I'd have a 14 in front, minus 9n equals 17. Then, if my goal is still to get the n alone, I need to move this 14. And the 14 itself is positive, so I would subtract 14, cancel these out. Please don't forget to carry down the negative. So we'd have negative 9n equals 17 minus 14, which is a positive 3. And no, your eyes are not deceiving you. Your answer will be a fraction, because if I'm trying to get n alone, I'm not dividing by 3, I'm dividing by what's next to n. So if I divide both sides by negative 9, I would cross these out and get n equals negative 3/9, which is better represented if I divide both of these by 3 as negative 1/3. Number 4 looks like it involves some distributive property first. So what I'm going to do is simplify both. So let me distribute the 4 in and the 3 in. So this would be 4 times 4, 16. 4 times negative w is negative 4w equals 3 times 2w, 6w, 3 times 2 plus 6. And now this equation reminds me of this one because I need to get my variables together on the same side because they're not currently on the same side of the equals one. So to be consistent, I'm going to move my variable over to the left. So because the 6w is positive, I'm going to subtract it, cancel. We have 16. These combined together, negative 4 and negative 6, is a negative 10w equals a positive 6. Just like this equation where we needed to subtract the 14, now we need to subtract the 16 from both sides so that this combines to be 0. Again, don't forget to carry down the negative. Negative 10w equals 6 minus 16, which is negative 10. I then would divide both sides by -10 because these are being multiplied. So it looks like my W is a -10 divided by -10, which is a +1. So the next examples, here's where we get into the real good times, that we're going to be combining like terms and sometimes doing the distributive property, and there might be variables on both sides also. What a great time, don't you think? So number 5, I scan both sides of my equal sign, and I notice these I cannot combine together, but here I can combine 5x and x, so why not make my life more simple? So I'm going to say -4x plus 3 on this side equals 5x minus technically 1x. Let me try that again. That was not that neat. So this is really technically a -1x. I'm having a little trouble with the markers, sorry. 5x minus 1x is 4x minus 13. So now, again, I want to get my variables on the same side. If I subtract 4x from both sides, they do cancel here, but it is a very common mistake. Do students think that they cancel here also? But -4 plus a -4 is a -8x plus 3 equals -13. So again, if we go through the lovely motions of solving and want to get x alone, we're going to have to subtract that 3 because it's being added. -8x equals -13 minus 3, which is -16. So for the third time in these notes, the answer is x equals +2. This next example here, it looks like on this side I could do a little distributive property, and what I am distributing here, remember, is really a -1 in front. Here it also looks like I can distribute. So let me get rid of the distributive property first. Order of operations says always multiply first. So I am going to do the distributive property because remember, can't combine in here, can't combine in here. So the only legal way to break the order of ops is by using the distributive property. So 2x carries down. -1 times 5 is -5x. -1 times -4, please be careful with the double negative, is a +4 equals, distribute here, 4 times -1x technically is -4x. 4 times 1 is 4. Let me definitely simplify this side. Here are my like terms. 2x minus 5x is -3x plus 4 equals nothing I can do over here, -4x plus 4. Okay, so kind of a pattern here. Let's move the variables together on the left. I'm going to add 4x on both sides because this is currently being subtracted in a way. 4 minus 3 is 1x plus 4 equals 4. Subtract the 4 over to both sides. So I have 1x equals 4 minus 4, or 0. If I divide both sides by 1, I get that x is just 0 divided by 1, which is 0. And it is okay for an answer to be x equals 0 because that is a legitimate number. So if you get that, have confidence. Okay. Last two examples, 7 and 8. Both of these, what I'd like you to do for a few minutes, and especially, let's actually just focus on 7 for now. I would like you to combine like terms over here and see how far you get. And for number 8, I would like you to distribute as much as you can, simplify, and see how far you get. For both 7 and 8, you are going to get some strange answers. We will go through them in detail, but I want to give you a little bit of a head start. So please pause your video now. Okay, so if we pick up with number 7 first, I notice this side I have no like terms, but this side I have this x and this 2x, or really 1x plus 2x. So I combine them to become a 3x plus 11 over here equals 8 plus 3x. Now, if any of you followed the same idea that we've been doing, you might have subtracted the 3x over to the other side. And you might have noticed, okay, this is canceled out like we've been doing so far. But some of you might have said, wait a second, 3x minus 3x cancels again. So on this side, I'm only left with 8 equals 11. And if I said in front of the class, if I said, guys, 8 equals 11, I hope you would look at me like, you're crazy. That's not true. 8 does not equal 11. So this statement right here is absolutely false, which means I have no x's, so I don't know what x is, but if I end with a statement that's false, that means that there's no solutions that work. So you could write your answer as one of two ways. Your answer could be no solution, because this makes no sense, so you could have this, or there is a symbol called null set that you could use instead, which is a zero, like an O with a line through it. This also means no solution, so I would accept either of those on future tests and quizzes. Number 8, what I did on both sides first was multiply or distribute. So let me do that first here. 2 times a is 2a, 2 times negative 8 is negative 16, plus 7 equals 5 times a, 5a, 5 times 2 is 10, then I have the minus 3a and the minus 19. My goal again is to make my life more simple, so let's simplify both sides separately before we move anything. On this side, I notice that negative 16 and 7 can be combined, and on this side, I notice that 5a and negative 3a can be combined, and 10 and negative 19 can be combined. Now remember, when everything is on the same side, you are just combining things. You're not moving anything. So over here, we would get 2a, negative 16 plus 7 is negative 9, equals 5a minus 3a on the same side is positive 2a. 10 combined with a negative 19 is a negative 9. So now and only now, when both sides are completely simplified as much as I can, is when I move things. So I want to make that very clear. Don't move anything until you simplify both sides. If you do, you're more likely to make silly mistakes, and I'm trying to teach you otherwise. Some of you might already be looking at this like, hang on, this is exactly the same thing. But let's stick with the same pattern for now. If I subtract 2a from both sides, this crosses out because it combines to be 0, and again, this crosses out. So on this side, I'm left with negative 9, and this side, I'm also left with negative 9. So if you look at this statement, negative 9 equals negative 9, is that to you true or false? Well, I hope you agree with me that this statement is absolutely true. If I said that negative 9 equals negative 9, you would say, well, that's true every single time. So unlike this one where the statement was ridiculous and it was no solution, this time, if something is always true, so I'll even write always true, that means that every single answer in the world can work. And how we write that is all real solutions. So you could write it out that way, all real, or just like this, there is a symbol. It kind of looks like a kind of a crazy R. You do 2 vertical lines and then make an R with that. This symbol here also means all real answers. So what these mean again is that for this example, anytime I see an A, I can plug in anything that I want. 1,000, I could plug in 1, I could plug in negative 1/2, anything. And this side of the equation will always equal this side. But this equation, I could plug in any x value I wanted and none would work. I could plug in 1, I could plug in 10, I could plug in 11, and this side would never, ever, ever equal this side. So I want you to be aware that this just means everything is possible, and this means nothing is possible. We will be practicing this idea more, probably after you're done with this video in the last part of class, and it will be on your homework as well. Guys, if you feel like rewinding and rewatching any specific example, you are more than welcome to do so. This is your time and your decision to watch the video for the notes. I hope this was helpful. Feel free to ask either myself or Mr. Foster questions if you have them. Thank you.